Hello, good evening, guys. Thanks for joining us. Today we are going to talk about running your test in production. Let me just share a presentation with you. Okay. So hi, good evening, everyone. My name is Nahum. I'm a software engineer in my background, and in both software engineering, but also performance and test automation field for almost last 20 years. I'm an expert in performance testing, working closely with open source community and with different tool vendors. And I'm also co-founder of Cloudbit. Cloudbit is a innovative testing and synthetic monitoring platform which helps developers, DevOps, and SREs to run, scale, and analyze their tests in both pre and post-production. And today I'm going to share my experience with running tests in production. We are going to talk why we need to run, or why would we like to run tests in production, what we need to know, what key measurements we need to gather. And on the second half of our talk, we are going to discuss the existing solutions and how you can do it yourself in-house. And at the end of our today's session, I'm going to show you a quick demo how it looks in reality. I'm going to use our product, but basically the idea is just to give you kind of a sense of how things look and how these measurements that we will discuss are implemented. I will leave hopefully enough time for questions. So you feel free to use chat if you have questions in the meantime. But again, I'm going to answer a question at the end, but you can just drop them in the chat and I'm going to review them towards the end of the session. Okay, sit tight and we are going to start. So first of all, we need to understand why we would like to run test in production. I mean, if we will probably talking a few years back, it would look strange. Why is the hell we need to run test in production, right? Tests is usually correlated with more with pre-production or development stages, and usually anything which has to do in production is usually more related to IT and less related to R&D and testers. And so it's basically the situation has changed for last years. More and more continuous integration, continuous deployment has evolved. So the need to assure quality in production has increased dramatically. And the reason is because our release cycle has shortened dramatically. And we have less and less time for proper slow testing and detailed testing, and we more and more use automation to test. And while it's great, it saves a lot of time. Still, we have a chance for defects to be leaked into production, and also the production systems are more and more complex, and they more and more rely on third parties. So basically, the risk of having downtime and shortages has dramatically increased. And on the other side, more test automation we have right now in our development stage allows us actually to apply it also into production and have a great monitoring coverage in production as well. So, one of, I think, obvious reasons to run tests in production is find leakages, defects that leaked into production. We all encourage it, just being users. It happened to all of us that somehow in certain stage, the flow stopped to work. It could be, a shopping website or a registration for anything, but it definitely happened to all of us that suddenly things stopped to work. And so this is a great example of defect leakage, which, not necessarily will be found in some straightforward user action, but might be found in some more complex operations, which can be more difficult to identify and find. On the other side, those might be very critical user actions that we really don't want to stop user, for example, from registration or from checking out. And so obviously more tests we can running in production, we can actually simulate user actions before users and actually identify any issues in our production flows using mainly UI tests. So of course, we mostly would like to run UI tests, but we also might like to run API tests, for example, which might be highly effective. And as you probably know already, in test automation, UI tests tend to be flaky and less stable, and API tests are super stable. So definitely combining both, running both API and UI tests in production can bring you a great benefit and balance between stability and coverage. So first reason why we would like to run tests in production, find leakages. Another reason is that we would like to measure user experience. So not everything that could happen in production is just a defect, right? Or just a shortage of functionality. One of also disasters that could happen to production environment is slowdowns. So it's a degradation in performance and slow response time. And as you probably know, now the user experience is the king. So we really want to give superior experience to our users and to our customers. And in so competitive landscape as now, a lot of services really fight on user experience. So if you provide a better user experience, you can get you can basically get some of your competitor users moving to your service. So measuring user experience is quite tricky, and is actually, if you run and you write your tests right and you run them in production, you can also measure and get notified when your performance slows down. Another very important aspect, especially for larger companies, is measuring service level agreements. So as more and more production environments rely on third parties and cloud services, so measuring both internal service level agreement and external service level agreement is extremely important. And actually to get ourselves and our vendors and suppliers accountable, this is the only way we can do. And surprisingly, actually running tests in production can help us to measure it. We're going to see it slightly later in our presentation. As I already mentioned, very important is to find defect before our customer do. And so, we can always wait for our customer support calls, but the best is always to identify issues before. And if we keep running our test in production, we can definitely do it much before our users find the same defects. Now, if you're familiar with canary deployment terms, so with canary deployment, it's super important to also run your test in production, because we often release features even to limited group of users, which not necessarily 100% tested. So this becomes even more important in both canary deployment and continuous deployment cases, when the chance of defects to be leaked in production are much higher than if we do deployment manually. And of course, we usually have a lot of key stakeholders, from product managers to IT managers, CTOs, CEOs, and so on. So, running tests in production gives us a single pane of glass of understanding how our system behaves in production, from failure and defects perspective, from performance perspective, and from service level agreement perspective, which is super important to measure it over time. And it definitely, once we can measure it, it makes it much, stakeholders, much both accountant on what's going on, and more calm about, knowing that everything works fine, and if not, everybody gets notified. Now, running tests in production basically is not a new idea. It's called synthetic monitoring for the last good probably 20 years. One of the first companies that did it was Mercury, which released back then Sidescope and BPM and so on. Their product the names keep changing, but basically the idea is not new. If you just, I will reduce the screen here, so if you like, you can read. So the idea of synthetic monitoring is basically simulating user actions in production, and monitoring critical business transactions and performance. And those tools exist for, as I mentioned, for over 20 years. And so some organizations, and actually a large IT organization, probably most of them using it. The only thing is that, or downside of those tools in the modern era is that basically the teams who are responsible to write those synthetic tests, because as you can imagine, those synthetic tests are actually UI tests you're running in development stage using Selenium, Playwright, Cypress, or whatever framework you use. So there are dedicated synthetic monitoring tools which have a similar approach to modern Selenium and other UI frameworks. But the downside of those tools in modern era is that IT team needs to maintain those scripts or those tests. And as the application systems become more and more complex, you can imagine that maintaining tens and hundreds of UI tests is quite a labor-intensive job. And if you think that you actually have all those tests already in development, so why not running them in production and basically maintaining, keeping the maintenance work in one single hand, rather than doing a double job and developing those UI tests, A, in development stage, and B, then in IT department to maintain synthetic monitoring scripts with different tools. So the idea of synthetic monitoring or running your test in production, not new. What today we are going to discuss how you can take your existing tests in development environment, which probably already have a great coverage, and move them in production. Now, one important term to mention, just to clarify, because there is a lot of confusion. So when we talk about synthetic monitoring, a lot of people confuse it with real user monitoring. And I would like to really, just in one sentence, to explain what is real user monitoring, how it's different from synthetic. So synthetic monitoring is actually, just simply putting in modern words, is like running your Selenium test in production, mostly. Again, it could be API, it could be other type of test, but say in most use cases, we just run our UI test in production. Real user monitoring is basically very similar to Google Analytics or other analytical tools. So it's all about getting a real user experience in real life. Now, the difference is on technology level is that real user monitoring using a JavaScript, which is embedded into your application. This is how it can report in real time. So it's very important just to get, understanding how your users using the platform. And I'm not speaking from business perspective, because this is where you have Google Analytics and other tools, but more from, response time, if there are any client-side errors. So this kind of stuff, it's really useful to have a real user monitoring. But if you like to monitor a more transactional flow, which means, I have a certain steps and I'm interested to see how this entire process works. So this is something which is very difficult to do with real user monitoring, because you really just get an interaction with the particular pages, and you would like to actually simulate these with proper UI tests. So those are not contradictions. I mean, ideally you need both. Usually real user monitoring will be used by your IT or software reliability engineers. While synthetic monitoring, this is something which you as a tester or you as a DevOps engineer or even you as a SRE can actually utilize, having a lot of UI or API tests already in your development environment. Okay, now we talk about why we connected it with quite existing synthetic monitoring thing. And now let's talk about what actually means to run your test in production, because by now you can say, hey, it's easy for me. I'm either already doing it or it's pretty easy for me to do it. I can take my CI tool, say Jenkins, I can just schedule it to run every 5 or 10 minutes. And here I have my test running in production, right? So if this would be so simple, we probably will not have an entire session on this. I mean, while you can do it in this way, there are a lot of additional metrics and measurements that we need to capture in production, which are usually not so relevant for development environment. So let's see what are there and what actually important in production, because there are slightly different between things we would look in development stage and things we would like to see in production. So first of all, in terms of terminology as well, when we say in testing or development word runs, right, test runs, in production we say checks. It's basically the same, but you know, sometimes when you see synthetic monitoring tools, they all talk about checks. So just to put it straight, checks and run is the same. What very important for us to see is how many checks we run in certain period of time. Okay, this would be almost also as important in development environment, but usually, you know, you would like to see it more from version perspective, you know, how your releases, builds, and versions are doing. Not necessarily would say, hey, I today ran 1,000 runs, and so I'm doing great. While in production, it's very important because it gives you a sense of how often you run this test, and so which means how frequently you cover your production from testing perspective, okay? Because, you know, in development world, you usually run something when there is a compelling event. So for example, you run your build or you have a new version or something happened, right? You wouldn't run your test just every 5 minutes for fun. While in production, you actually would usually like to run your test as frequently as possible, to basically not to leave too much time when your system is not under supervision or when you don't know what could happen. There might be a shortage, but you can't figure it out because your tests are not running right now. So amount of checks and frequency is very important in production when you run your test in production. Another very important term is availability. So basically availability is almost one-to-one with failure rate in the development stages. Okay, but it's more from coming from production when a lot of systems are measured on their uptime and availability. You probably know this 99.99 availability, right? So it's for us, it's very important to get percentage of time or percentage of checks which succeeded and which failed. Okay, so this is one of most important and basic measurements we have in production. Another very important measurement, and sometimes in some tools it could be called duration, in some tools it's called response time, in some tools it's called performance. But basically the idea is to measure our the time both the entire test, or we call it monitor, the entire monitor is running, and also measure transactions, which means specific actions or specific interactions to understand how those actions or those transactions are changing over time with either increasing load of users or with different times over day and so on. So this is also very important. And while we usually will measure test duration in development stage just to see our velocity, which means how fast we can run this test, or, you know, we're running a lot of parallel tests and we would like to reduce the time we're running the test so we can run it more often, or we can basically deliver results as soon as possible, because in development stage, the motivation is, hey, we have a build, we want to run the test as soon as possible because we want to see results as soon as possible. Now here the motivation is different. Here the motivation is to understand if we have any degradation in performance or we have any problem how the system performs. And now remember, so in production we have two key measurements. First is availability / failure, which means do we have any failure or downtime right now? And the second thing, which is equally important, is measuring performance and duration. So those are two most important type of measurements we would focus in production. Another very important measurement is which we can gather from availability is downtime. And downtime is measured usually not in percentage, but more in seconds, minutes, or hours. And in a lot of the organizations, they have a quote. For example, you can have, I don't know, 2 minutes or 5 minutes or 10 minutes or 1 hour of downtime a month. Okay, so usually downtime measured in minutes in period of time. So downtime for months, for last month, or for last week, and so on. And downtime is amount of times that system or transaction wasn't available, which means it was in failed stage. And uptime is exactly opposite. Okay, which means how many, and this would be usually in hours, how many hours overall in last week or last month our system was up. So those are also very important measurements. Another very important type of measurement is SLA, which usually used by management and by procurement team to measure both internally how we comply with our service level agreement and how our vendors and third parties comply with agreements we have with them, right? So for example, if we rely on certain service, say CDN, right? We caching some of our resources on some CDN network, we usually will have SLA agreement with this vendor saying, hey, this is your availability, this is availability they promise us, and this is a performance time, or response times they promise us, and so on. And we definitely want to measure it, okay? So SLA basically is a set of rules which either based on performance or availability, which defines, and it's usually would be based on 3 or 4 severities. Okay, so we can say, hey, critical severity, you know, if our SLA, say, based on availability is below, say, 98% or 99%, you know, so we will have then a medium severity if it's somewhere in between, and we will have low or warning if it's really close to where it should be. Okay, so SLA is basically a set of rules measured in performance and availability, which describes our agreement or our commitment, either internally or with external vendors or service providers. Another very important thing in the running tests in production is actually geographical location in running those tests. So, you know, when we're running in the development environment, it's less important where actually we are located. We usually would run tests within a network location where our, you know, staging environment exists. While in production, we want actually to run the test with from as many locations or from key geographical location when our customers are coming from. And this is very important because, you know, some locations might not be available because, you know, we have some multi-zone scalability mechanism and so on, so forth, or our servers are now down in certain location. So it's very important to run your test from multiple locations and then being able to compare different locations both in real time and over time to understand if we have certain performance or availability issues in a particular location. Okay, it also helps us to understand if performance issues are system-wide or they are specific to a particular location. Okay, so location availability performance is super important. And another term, just which usually we don't meet in development, is maintenance windows or maintenance time. Now, we all know that we need to get the system down from time to time for larger maintenance. And we usually would do it in weekends, at nights, and not that often. But once we do it, we obviously, first, of course, we want to notify our customers, but we don't want to measure this time, and we don't want to include this time into either SLA or duration or availability or alerts. We don't want to wake up people at night. So it's very important whenever you build or use synthetic monitoring solution, you run your tests, even using a simple, say, Jenkins method or your CI method, it's important you will allow to define maintenance windows, while in those windows, you either will not run those tests or you will just ignore the results. Okay, let's see if we have any clarification questions. Okay, no, we seems to be fine. Now, another thing, when we speak, so we spoke about, you know, availability failures, catching failures. I think this one is pretty obvious because, you know, we already all as a testers or DevOps engineers, we all know that we actually, everything we run from testing perspective, we want to add assertions, we want to add verifications, we want to capture defects, right? So this is the easiest part. More complex part is how we measure performance, how we measure, you know, transaction duration, how we extract more interesting data. And so when we speak about performance, we need to divide it into client-side and server-side performance. So the client side, it's simple. It's something which is related, say, if it's a web application to a browser, or if it's a mobile app, then it's related, obviously, to something that's running on our devices. And server-side performance is something that's happening more on applicational level or on our servers. Now, there is a key difference, and let's talk about it. So when we speak about client-side performance, so it's usually focused on how our browser renders a page. Okay, so it's probably you probably understand it, but just to mention it. So browser, basically, when we put certain URL into browser or we click certain link. So first of all, of course, there is a network part when we connect to our server and we ask for a certain HTML page, or if we do an API call, it's the same, right? And then we waiting, there is a DNS time and so on. We'll talk about it in a moment on server side. From client perspective, browsers start to work from the moment it gets a page, okay? So once it got an initial HTML page, it starts to, we call it DOM, dynamic object model. So DOM is basically a reflection of our HTML page into in browser memory. So browsers start to proceed this DOM. And so we have certain events that we need to understand in client side. It's called DOM loading, which means, we got our first HTML page and we start to proceed it, okay? This is still time when we see a white page. And why it's important? Because we need to understand how client-side performance reflects on user experience, right? Because, user doesn't care if our problem is a network, if we are slow because of network, or we have too much JavaScript into our page. The most important for user is just to get a quick response. And when we talk about quick response, usually it should be below 2 seconds. Some research say max 4 seconds. Anyway, it should be fast, okay? And so the client-side performance is all about understanding if the way we load the page, the way we render the page, right? The way our front-end developers wrote our application is efficient enough given the server-side response well, okay? And so we need to understand here a few major events. So DOM loading event, and you see the link, so you can read more extensively about it in the link below. So DOM loading means we got our main HTML page and we start to proceed. DOM interactive, this is a very important one, means that we proceeded it initially. We draw, right, UI components based on our initial analysis, which means by this time, the user can start interactive with the page. So user by this moment starts already see from white page, start to see actually our layout, which is very important because it means the user can start to get engaged with our page. So the first thing we need always to make sure is that DOM interactive is as short as possible, okay? The second one is DOM completed, which means we proceeded the DOM, we loaded everything which was attached straight to the page, and we now start to proceed additional events like, JavaScript start to run and some things start to happen. And so while still user might see some changes in layout because we're still running some JavaScript, which might change the things on the page, but the major part has already been loaded. And the last one is load event end, which means, all the JavaScripts are completed, everything is completed, and user has the final layout and has all the functionality ready. So it's important to understand those times because sometimes the problem is, and we'll talk about in a moment, is or more network or a backend side. Sometimes the problem is that the structures, the way front-end developer structures the page is too slow for loading, and sometimes there are just too many things going on in JavaScript, which makes user experience even slow. And when we speak about performance, we need to understand those parts. Now, just to mention, and I'm not really going to do deeper into it, but you can read it after the session. The important part is that every modern browser has what it called navigation timing API. And those API, we can either extract it manually when we use things like DevTools in Chrome and other browsers. And we can also access those metrics from our UI test. So Selenium supports it, Selenium 4 supports it out of box. other frameworks like Playwright, like Cypress, they all support it also natively. So basically, you can get much more detailed measurements of how your page is loading from network perspective and from navigation, which means from client-side perspective, using navigation timing. So I really encourage you to read about it. Again, it's not our main topic now, so we are going to skip it and go further. Now let's talk about server-side performance. So server-side performance it's all about how fast we can bring the data our client-side needs to display information to the user. And it's important to understand that server-side performance, it's again, there are a quite large bunch of measurements, but we need to understand mainly how our network works. So the one of the most important things in resolving how we connect to network is DNS resolve time. And again, I'm not going to get what is DNS, so you can read it later on, but it's very important to understand that still a lot of website performance are impacted simply by DNS, resolving DNS records. So the DNS resolving time is very key measurement, and when we measure server-side performance, the connection time it takes, the connection time is basically how long it takes to open our TCP socket with the server, and it can be impacted by a number of things. And send time is the time it takes us to send requests. Usually send time would be relatively fast unless we upload some file or send some extensive amount of data. And now time to first byte is very important measurement, because if we previously spoke about DNS connect time and send time, so it's usually more relied on network rather than on our application. Now, time to first byte is actually a first measurement that we actually can measure how fast our applications start to respond, okay? So if time to first byte is slow, and usually time to first byte means time to first response byte, okay? Which means when the server starts to send us response, okay? So the time to first byte is very important to measure actually how fast our application works. So if this time is slow, it means usually our problem is more on applicational level rather than on network level. And the last one, response time, and it's not the last one, but usually those are, I would say, 5 major measurements that we would pay attention to. And response time is the overall time. So if we send a bunch of data and the response time is very slow, it means usually we have some problem with our network capacity, either on our server side or somewhere in middle, or maybe sometimes on client side. So those are very important measurements to pay attention. One more thing to mention is Waterfall. So Waterfall is basically the way we show network traffic in some kind of flow chart, as you can see here. And now the big, basically the big benefit of working with performance waterfalls. And performance waterfall, you can see it in almost any modern browser today. I mean, it's in the dev tools of Chrome, Firefox, Edge, and other browsers. So you can actually see it by doing, by opening your dev tools. But you can also, if you record your network with some other tools, say as a part of your Selenium test, you can store it in the HAR format, and basically you can view it in, there is a simple HAR viewer JavaScript, which basically generates what you see. The idea is that the performance waterfall really allows us to see 2 things. It allows us to see the network performance. If there are things, as we mentioned, DNS lookup, connection time, and so on, if there are any network level issues. And B, it allows us to see a client-side performance. So, how fast it takes us to proceed the DOM. And, usually we can see if there are some JavaScripts which are loaded later on, or some resources which are loaded later on, we can easily see it here. So it's a great analytical tool really to improve both our backend and front-end performance. Now let's speak about tools. There are obviously some existing tools out there, and we also are going to speak about how you can do it yourself in-house. So, I divide tools into classics and into second generation tools. So the classic tools, those are tools which exist for quite a few years. As I mentioned, one of the first companies was Mercury, which then was purchased by HP and then was purchased by Micro Focus. So those are classical tools which are oriented on synthetic monitoring, which means they can't run your existing tests in production. You will need to use a dedicated tool to recreate your test in production, okay? And as I mentioned, I mean, the good part of this is that your IT department usually can do it as a self-service. I don't need you. The downside of it is that your IT department or your SRE team needs to catch up all the time with the ongoing coverage that you're already providing in your development and testing stages. Now, the second generation of tools are the tools who are coming from observability field. And when I say observability, usually those tools are oriented on monitoring your infrastructure or profiling your code and your performance. And those are major players. There are much more tools than those, but those are major players on observability market. And all those vendors, they also have a synthetic monitoring tools as an addition to their portfolio. Now, the advantage of using second generation tools are that they are all integrated with your infrastructure monitoring, and which means you can correlate easily. For example, if you have failure, you can easily go down to logs and identify a line of code where it happened, or to code profiling, which reducing dramatically the root cause analysis time. So this is big advantage to interconnect or use the same vendor which provides you both synthetic monitoring and observability tools. The disadvantage is the same with the first generation tools, is that you still need to use proprietary engine. And for most of those tools, you can really run your test, just take your test and run them with those tools. Okay, so you will need to rewrite them. There is a third generation of tools, which happen to be the company that, I'm one of co-founders and I'm managing this company, Cloudbit. I'm going to show you at the end of this conversation, which actually allows you, so it basically complements DevOps, and it allows you to run the tools, your existing test in production, and getting everything, both integration with your observability and all the metrics we discussed. Now, I know that a lot of us are technical enough and would like to do things ourselves, and would like to reduce costs to our companies, and basically to use our existing tool chain. So let's discuss what it takes to build something like this by yourself. And again, it's not about just running tests in schedule. You can do it easily with Jenkins or your existing DevOps tool. It's all about how you extract the right data from your test, and how you measure it, and how you do an actionable insight from it. You need to send notification, you need to gather information, you need to send reports, and so on and so forth. So from tooling perspective, and again, this is a tool chain you're probably already using, at least some of this. So when we speak about testing, so we can use either our existing API test, for example, we can use Postman, or we can use any other, more programming-oriented tools like Rest Assured to be using Java or any other programming language. With UI testing, we obviously would use usually something either from Selenium world, or the new generation of UI tools like Playwright, Cypress, and others. So I think this is obviously thing. I have a slide which we'll talk in a moment, how you can utilize those tools and how you can extract more data from those tools than you usually would do for development stage testing. Now, the important part is how you actually do a data analysis. And as you can imagine, if you run your test every 5 or 10 minutes, you will have a big data problem because you got a lot of data, and B, you need to analyze it, and you need to extract and aggregate in time and resource efficient manner. So, one of tools I really personally like is Elasticsearch and Kibana and all the Elastic Stack. I think they provide a great combination or great balance between simplicity and power. There are plenty of other open source and commercial solutions, Prometheus, InfluxDB. You can use Grafana based on Elastic, or Prometheus, or based on InfluxDB, and so on. There are many other great commercial solutions. So you need to pick when you do it, when you build such solution yourself, you need to pick one of those solutions in terms of, sending all your metrics, sending all your data, and you need then to combine your UI or API test with reporting those stats into those tools. Some of tools like Selenium, you can find reporters that are already integrated, say with Elastic. With some, you will need to write it yourself. And of course, the third thing you need when you build a solution yourself is, of course, some kind of schedule which will run your test in cycles every, usually a few minutes. And well, you can use your existing CI tools. You can use Jenkins, CircleCI, any other tools. And of course, if you use your cloud-based tools, then you will benefit from cloud infrastructure. And if you use your local tools like Jenkins, you will usually need to put some scalable infrastructure, especially if you plan to run a lot of your tests in production. It's important to mention that we never run all our tests in production, because usually we'll have some sensitive actions that we can't do in production, like we can't usually do a payment unless we have some special setup with our payment providers, and so on and so forth. So we not necessarily would like to cover everything we cover in our development stage in production, but still we might be ending up running tens and hundreds of tests in production, so you might need an infrastructure for it. So those are three categories of tools. You need to build a basic implementation of your synthetic monitoring tool based on your existing tests. Few tips when you do it. So first of all, stability is a king. So, if we can usually live with somewhere between 5% of flakiness, which is really low, to 20-30% of flaky tests in development stage, which I would say is very often, it's very common in a lot of organizations. In production, we obviously can't live with flakiness at all, especially if we use those tests also to alert our teams. We don't want to wake up people at night because we don't properly handle some Selenium, element not found thing, for example, right? So stability is super important here, and we need to invest extra time into wrapping our tests and basically rerunning our tests and doing everything before we actually declare our test has failed. Okay, so this is a very important part, and you might need to invest extra time here to build mechanism around your existing test to prevent false positives here. Another very important thing is notification. So we obviously want to notify our team and people and relevant people if something happening. And here we can use services like PagerDuty, which will do it for us. So basically we just can say, hey, PagerDuty, notify this group, and the PagerDuty will take care of notifying either through email, SMS, and all this, or we can just do it from scratch. It's up to you. So basically, but the notification part is super important. Metrics, as I mentioned, it's very important for us to measure it right. And usually from metrics perspective, very important is to capture minimum, maximum, average, and percentile value. Percentile value is super important, because usually if we want to filter out some peaks or even some false positives, we would usually work on somewhere between 90 to 95. Some would work even on 98, 99 percentile statistics, because average not always gives us a clear picture. So percentile is very important, but also minimum, maximum, average values will help us to understand the performance limits. Reporting, when it comes to reporting, as we mentioned, availability, performance, it's must. SLA, you might find it's difficult to measure SLA when you build this solution from scratch, because you need to allow to define some rule-based SLA. I will show in a moment in our implementation. You can do it on second stage. I mean, it's nice to have, but it definitely is something which senior management would like to have over time. And failure root cause analysis is very important. If you can link to your observability tool, if you have one, and kind of provide a single click root cause analysis, this might save super critical time when you have a downtime in your production, and every minute counts. From integration perspective, important to not just run it and leave the results. Say if you use Jenkins or other CI tool, it's important to integrate with your production tools like incident management, like ALM tools, your operational tool. And so it's very important to interconnect it. Again, you can use services like PagerDuty, which will be your broker, or you can do it directly. It's up to you. So those are main tips, particular stuff about UI tests. So if you're in Selenium or Playwright and Cypress or a similar solution world, so it's super important to capture navigation timings. As I mentioned, you can access it from each one of those frameworks. It's important to record the network traffic. And again, it's almost for most of frameworks today, it's out-of-box functionality. It's super useful. It's usually heavy on storage, but it's super useful to record videos of your test because so much helps to understand both performance and failure and the defect issues, and capture browser logs. It can be super helpful because a lot of front-end issues we can easily identify when we open our dev tools and we see all these JavaScript errors. And if we can deliver it to our development team, it can save them tons of time. So really recommended. So those are just basically, things we need to take into consideration when we're building our own solution. Just to show you how the final result looks like. So I'm going to show you what we build in Cloudbit. And again, just take it as an idea, okay? What you can build inside your organization. And of course, if you like to see it more closely, you will see my contact details, drop me a message. I will be happy to give you an access to the platform. So let's see how it works. So basically, again, just to remind you, Cloudbit is a synthetic monitoring and testing orchestration solution. So basically what we do, we hook our tests using Git. So say we wrote our tests, say in JUnit and Selenium, just an example. It could be anything from Playwright, Cypress, Postman, and anything else. So say we just will use as an example, say we wrote our test in JUnit and Selenium. So we just hook it up to Git. We hook Git repository here. And from this moment on, we can define our testing monitor and the way our monitor will look like, as you can see. So the major metrics, if you remember from our presentation. So first of all, I want to understand my current status. So I would like to understand if my system now is up or down. We usually will use our last test result to understand this. So if our last test has failed, we usually will mark the current status as downtime, as failed from our system perspective. We would like to see amount of checks. So checks, again, it's test results using our testing or development language, and pay attention that we will use it usually over a period of time, because in monitoring in production, it's all about timing, okay? So at the moment, we're looking for last 24 hours. We can obviously change it and look at last 7 days, like 30 days, and so on. And so here we see how many tests we run over a period of this time. Here we can see availability, and availability, just to simplify, it's basically a failure rate that we use to measure in our testing environment. And very important is performance. So you remember I mentioned that some tools call it duration, some tools call it response time, and some tools call it performance. Now here it's important because it depends what you measure. The label itself is less relevant, but what's important is what we measure. So here in Cloudbit, what we allow you to do, we allow you to choose what you measure and call this performance. So if we go to monitor settings, you can see that you can define if performance from your perspective is overall test duration, is transaction average time, or step duration. And this might make different for you the way you measure your performance. So some companies measure performance from end-to-end time. So if my test is running 10 minutes and now it's suddenly running 15 minutes, okay, I will start look at it, okay? But if it's now running within the 10-minute range, so I will usually assume that my performance is okay. Other companies might measure it on particular transaction side. So for example, my registration transaction, if it's start to be slow, I will raise a red flag, because this is, for example, this most important thing for my business is registrations or checkouts. So this is very important. So performance, again, here from our perspective is flexible. You can define it. But if you just want to start getting started, you can just define as a duration of your entire test. I think will give you a good enough indication. Another important part here is our charts, because we not just want to see now what's happening with our platform, but we also want to see if we having some problem which increasing and becoming more severe over time. So for example, here we can see that we had a downtime today around 12. And we usually would like to take a look at it. Okay, so we obviously got an alert at real time when it happened, but we also can see, hey, if I see certain pattern here, right? So if I have a downtime every 2 hours, or I have downtime at a certain time at night or a day, then I might start to see a pattern and might understand that I have a recurrent issue that's happening. The same goes with performance. So it's very important to pay attention, whatever you measure, if it's an entire test duration or anything else, to pay attention, if you have a certain time in the day when you might have a more traffic, or maybe there are some third parties that you rely on that are slower. And it's very important to see how your application performance in certain time of the day or in certain days in a week. Now, here are SLAs. You remember we discussed SLAs, just to quickly show you how SLA definition looks like. So you remember I mentioned that SLA could be based on availability or performance. Here you can select if it's availability is in percentage, right? So 99 or 95%. If it's performance, then it's time. Here in our case, we'll define SLA in seconds. And now I need to define a scope to SLA. So I can say, hey, I will define the general SLA from monitor perspective, or I can go deeper and define SLA from particular transaction perspective. Okay. Again, if you're just getting started, I think general SLA would be fine, but more you go with synthetic monitoring and running your test in production, especially your IT department or your SRE team would like to see it also on transactional basis. And then the last thing is that I have 3 levels here of thresholds. I have normal, okay, so which means anything below this will be within a normal range. So I don't need to get panic. I don't need to notify anyone. Warning range, which means it's not that critical, but I would like at least measure it and sometimes even notify, but maybe less, priority teams, like just, to notify, say some engineering team. And if it's critical, I might want to notify even top management. So it depends how, your notification hierarchy works. So those are SLAs. Of course, alerts, as I mentioned, it's very important to send alerts. Now, it's very important to be able to send alerts to different groups, because it depends on what's your failure. So you might either wake up or just notify different type of people in your organization. So whenever you build your solution, whenever you choose a solution that can run your test in production, you need to pay attention that it allows you to define different type, or we call it triggers, different type of failures, and allocate them to different type of groups. So this is super important. Another super important thing is, you remember we spoke about being able to reduce false positives. So here you can see we have a special feature coincident policy, where you can say, my failure is actually for me is not just the last failure, but I would like to see if I'm failing for the last 3 times, if I did 3 runs and I failed 3 times, then it's a real failure. But if I failed only once, that it probably could happen, right? Or for example, if you're running from multiple locations, you can say, if I'm failing from one location, it's not that severe failure. But if I'm, failing from 2 or more locations, then I want to wake up everyone. So those type of things are very important. I will not show you more because we are short on time, and I want to leave you some time for questions. But again, as you saw, this is how all the theory we saw before could be implemented, either with your in-house do-it-yourself solution, or what you need to expect from tools which provide you an engine and analytical mechanism to analyze your test in production. So guys, I will show just a last slide with my contact details. Feel free to connect to me on LinkedIn, or drop me a message with questions. Again, thanks for listening, and it's time for questions. Please either open up your mic and ask your question, or just drop me a message in the chat, and I'm here to answer any of your questions. Guys, any questions? Okay. So if no questions, thank you for your time. I hope you enjoyed and I hope it was insightful for you. Again, as I mentioned, feel free to drop me an email if you have any further questions or you need an advice. You have my details here. And have a great evening. Hope it was insightful. See you, by the way, to mention, we do another session, more hands-on session, which will cover some of those topics on 1st of December. Please check it out on committed website. So you're welcome to join it, and we will be much more hands-on. We will see different frameworks, how we can extract different data. And so you can see some of things we saw here are implemented into life on more workshop. It's not really a short session, it's 2-hour workshop. So you can see it's implemented on December 1st session. So you're welcome to join. Thank you very much again and have a great evening. See you all. Bye-bye.